Cool. All right. Hello, everyone. Thank you very much for coming along to the talk. Oh, hey. Thank you very much. Cool. So yeah, my name's Jack. I'm a developer evangelist at a company called Pusher in London. And today I was going to talk about building web apps with components, but we kind of had a bit of a change of plan, and the talk is going to focus a little bit more on React. But hopefully still the talk will be applicable to other frameworks, even if you're not working specifically with React. As I said, my name's Jack. That's me on Twitter. Please do come and follow me. I'll tweet out a link to the slides later on, so please don't worry about writing down any slide notes or anything. I'll tweet them out later. I work for a company called Pusher. We're a company that makes it really easy to build real-time applications. Please come and chat to me about that. It's also my birthday today, so it's really exciting to be celebrating this in Infoshare. Thank you. And having been here last year on this stage, it's amazing to be back and amazing to be doing it on my birthday as well. So thank you very much to the organizers for putting the event on and for inviting me back. As I said, I'll tweet out the URL to the slides later, but they'll be up after the talk on speakerdeck.com/JackFranklin. OK, so on to React. Who's heard of React? Cool, that's good. There's a lot of people. The Stack Overflow survey this year said it's trending by 311%. I don't really know what that means, other than it's pretty popular. It's kind of made a big impact onto the industry and how we build applications, and is certainly something that's here to stay for a while. The most important thing about this talk, I think, even if you're not going to work with React or you're not building React applications at the moment, is that the ideas in React are more important than the actual framework itself. In the JavaScript world, we see frameworks come and go a lot. There's a new kind of framework out every single week that claims to be the next big thing. And at some point in the future, React might no longer be a thing we're all working with. But what I'm confident in is that the ideas that React has introduced will carry on into other frameworks, and we'll be working with them for a long amount of time. So hopefully, even if you personally are not working with React or don't plan to, you can pick up another framework and still use some of the ideas from React and from this talk as well. And what it all comes down to, really, is this idea of building applications in a component architecture. And this isn't something React introduced. It just kind of went along with it. Most frameworks now are buying this idea that we build applications built out of smaller pieces that we call components. If you think about the Facebook application, you know, it's got a header, it's got a navigation, a news feed, and a chat at the bottom with someone. Each of these is an individual component, and each of those themselves are made up of lots and lots of smaller pieces. What we end up with is this tree of components, if you like. We have our big main app component at the top, and then maybe the header navigation components. Each of those have more components inside them, and so on and so forth. And usually you can map any kind of website like Facebook into all these components. Building applications in this fashion gives us a number of benefits over the more traditional, maybe controller-based approaches we've taken in the past. The first is that each component can have a single responsibility. You never end up with components doing things across the entire application because you're splitting it up into lots of bits where each component has a very specific part of your website that they're responsible for. This also means, and this is particularly important in a bigger development team or working on a bigger project, that you can work in isolation. If you are working on, say, the chat component, you're not going to accidentally break the header component or the navigation component. And more importantly than that, you don't have to have in your head as a developer all the logic contained in the header and the navigation and whatnot. You can zoom in and focus purely on the little bit of the application you're working on. Doing this also makes it really easy to test, because we don't have these humongous components doing tons of stuff to test. We have lots of little ones that we can test very easily. And this lets us build up big applications pretty quickly by composing lots of these small components together. What you'll often find as well is once you've got some components, you can reuse them across different projects. So say we have this component A. You can just about make out that's A. This might be a pretty small piece. We can put 3 of them together, and this might make another component B, which is actually made up of smaller pieces. Once you've got this, you might be able to put lots of them together, and then you end up with this component called C, which is made up of all those pieces put together. So by starting with very small building blocks, we can combine these together to put our applications together almost like Lego bricks. And it's actually amazing in practice how well this works. So that's the general idea of building applications in this component-based architecture. The rest of this talk does focus on React and how React works, but this notion is popular in most other frameworks at the moment. Ember uses this and kind of encourages you to use components. The new version of Angular, Angular 2, very much focuses on components. And most popular frameworks out at the moment are doing this, and React is no exception. So we're going to dive in now and look at some React code. All the examples, I've got links to JS bin, where the examples are online, so you can have a look at them. As I said, I'll tweet the slides out once I've sat down after the talk, so please don't rush to write any code down. You'll have all the code afterwards. So if we wanted to start with the hello world of React, we're going to create a React component. So the first thing we do is call react.createClass to create one of these components. And in React, every component has to have a render method. And the render method just says what this component should look like when it's placed into the browser. This is your representation of the component that the user is going to see. And you might be looking at me weirdly right now because the next bit of code is kind of weird. We're returning what looks like some HTML called hello world. So you see this component hello world will render to the DOM a string hello world within a heading 1 element. This is a thing called JSX, and it's an XML or basically HTML-like syntax for creating React elements. And when most people start out with React, they think this is the worst idea ever. And for a long time, I thought it was also the worst idea ever. The notion of putting HTML into your JavaScript seems pretty weird and pretty foreign. But what's really important to remember here is that actually it's not HTML that you're putting into your JavaScript. All JSX is a small syntactic layer that makes it easier to build React components by writing what looks like HTML. But technically, it's actually JavaScript in your JavaScript, which makes even less sense than HTML in your JavaScript. But if we look at this, what actually happens in reality, if I have I'm creating a nav component up the top there, what this will get compiled down into is the code on the bottom. All we're doing here is we're adding a little syntactic sugar that makes it nicer to create these components. You could absolutely stick to writing the bottom bit of code there, and you never need to deal with JSX at all. But in practice, I found that the JSX syntax makes it much nicer to work with components. A nice side effect of this as well is if you have non-engineers who need to work with some of your code, maybe designers or other people who need to edit this application, who aren't too familiar with JavaScript but are familiar with HTML, they can often make changes much easier because you're working in something that is effectively HTML or very much looks like it. So you can write this all without JSX. Throughout this talk, I will use JSX because I'd say nearly everyone who works with React does. So once we have a component, we have the hello world component, we need to render it to the DOM. To do this, we use the React DOM package, which includes a render method. So I first call render. I give it my component, like so. I then give it a location to render into. And then if we go to the JS bin, you can see we do get hello world back on the output. This is a pretty boring component. I think including the whole of React just to get hello world onto the page is maybe a little excessive. But thankfully, we can do a lot more with components. The components can be configured to behave exactly how you need to. This is really nice because often you'll have maybe the same component needs to be used 2 or 3 times on your application. Maybe it's a component like toggle or a toggle button. You might need to use it a few times across your app, but configure it slightly differently every time. We can configure our components using what are called props, or properties to use their full name, although they're always referred to in React code as props. So I'll use props for the rest of the talk, but they're properties. So say I create another React component called person, and this is responsible for rendering to the DOM some information about a particular person. In my render method now, I can refer to this .props.name in the curly braces and this .props.color. These are 2 properties that the component can be given to change how it behaves. Now when I go to use that component, I can pass in name equals Jack and color equals blue. Again, looks very much like HTML. And then you might just be able to make that out, but it does say name Jack and favorite color blue on there. So by doing this, we can make components that we can tweak slightly by passing in different properties. This is really, really useful. What's really important to note, though, is that props aren't just for Christmas. Once you allow a component to take a specific property, it's going to be able to take it for the rest of time, effectively. It's very easy to make components incredibly configurable and pass in 10 different properties that configure it in 10 different ways. If you're doing that, you should probably consider if actually you want 2 or 3 different components. Properties are really great, and it's great that we can configure them and pass them in. But if you're doing too many, it's probably a sign that really you want to split that big component down into smaller components. Once you get past maybe 3 or 4 different properties that you're giving a component to change its behavior, you probably want to look at splitting it up. Importantly as well, properties are only for data that the component isn't going to change. So properties are entirely read-only. They can never be edited by the component at all. And in a minute, we'll see how we can deal with data that does need to change using state, but properties can never be changed by the component. Once they're given to the component, that is the value they have. The component can never change them. Components with just properties are actually brilliant because they're very easy to work with. They're way less likely to be buggy because you're not dealing with data that's changing all the time. So in general, you should strive to have components that have just properties and no data that's changing. Of course, in a modern web application, we do have to have data that changes, and in React land, we call this state. So I'm now going to create a little toggle component that's called on/off. And this is going to have a bit of state which dictates if a particular value is true or false. So I define this getInitialState function. It returns an object that represents the state. The state here is data that this component owns and can change. And I set the key on to be false. And then down here in my render, depending on if the state is on or not, using a little ternary, I just toggle it between the string on or the string off. So that's great, but now what we need to do is hook up a button so the user can click to toggle that between on and off. And to do this, we need to use events. React comes with a full event system that's really easy to work with, and it deals with cross-browser incompatibilities. You don't have to worry about that at all. So button, I'm just going to say the button, when it's clicked, call a function called this.toggle. And then in the toggle function, I'm going to call this.setState. And we pass setState an object with the new keys and their values, and it will overwrite any existing keys that match. So in this case, it's going to overwrite the existing value of on in the state with whatever by flipping it, so negating it from true to false or taking it from false to true. You have to call this.setState because that's how React knows that some data might have changed, and we need to maybe re-render and update the DOM. And if we do this, is this the video? That's a link for you to try it. I think this might be a video. And you can see I'm clicking toggle there, and we're swapping between off and on. And notice here that in all this code that we had, we didn't ever have to deal with the actual logic for re-rendering. React does that for us. This is one of the really nice things about React, is we just change data, we change state, and we trust React to do a good job of updating the DOM for us. And this is really, really powerful, and React is very good at doing it very efficiently. Half the reason it can do this is because its render function is what's called a pure function. Anything it needs, it gets as input, and it's always going to return what's called a virtual DOM. So the way React works is the render won't actually write to the DOM, it will return a virtual DOM, which is like the DOM, but just in JavaScript in memory. It will then compare this virtual DOM to the real DOM in the browser that the user's seeing, and figure out what's the minimal set of changes that are needed to make the real DOM match the new virtual DOM. This means that changing a piece of state is really cheap, because the only bit of DOM that gets re-rendered is the tiniest bit that's changed and nothing else. So you can think of render as a function that takes a state and returns a virtual DOM. Also, if you call render with the same state, it will return the same virtual DOM every time, so we can avoid doing needless re-renders pretty easily. What's really nice is you don't have to worry about this. It's all under the hood, but I'd quite like to talk a little bit about how React does it. So state is data that the component will own and can change over time. You should always try to use props by default and only go to state if you have to. It's better to try and avoid data that changes because it's more tricky to work with. As a small bonus, if you're writing components that only ever take properties, you can harness a feature that I think was added in React 0.14 called pure functional components, otherwise known as dumb components. To define this component, such as showName, I actually just define it as a function. This function takes in properties as an argument, and the body of the function is treated as the render method to the component. So here's my whole component, it's just a function. And then when I render it down the bottom, I can render it just like I render any other component, but this one is just a purely functional component. You're not able to access state within this component, you're only able to access properties. In the release notes, when this feature was first added, there's a couple of really nice quotes from the blog post. This pattern is designed to encourage the creation of simple components that should comprise large portions of your applications. So the thinking here is that you should have your application made up mostly of these pure dumb components that don't deal with state, and try and only have a few that are dealing with data changes. What's really nice as well is that the React team think that in the future they'll be able to optimize performance and increase rendering performance when people are using these dumb components. So by using them now, you're going to give yourself a performance boost in the future when that stuff lands in React. You'll be getting even more efficient rendering for free. And even in large applications, React is really, really efficient when it comes to rendering data onto a website. If you think of this big app like Facebook and this tree, and imagine that the component and that red component, some data changes in that, React knows now, because of the tree structure, the only bit it needs to check is that little bit there. So it's always avoiding doing as the checks if it possibly can, and avoids re-rendering as much as possible, and only does the minimal amount of work. In practice, it's really, really, really good at this. What's really nice when we're working with React on large applications and small is we don't really have to deal with performance for a while. When you do hit performance issues, React also provides a lot of really handy dev tools to help you find it and track down the issue. So really, what I really want to emphasize is this idea of components and components and components and components and components and components and components. As you build React applications, split your components down very small and have lots of them in a big kind of tree structure. You should definitely do that pretty aggressively. Just to give you an idea of how that might work in practice, imagine we're now building a React application. We're going to build the new Gmail, or the next mail app, because there haven't been many of those. So if I create a mailbox, and this component is going to have some state, it's going to have some messages. You might in reality get these from some API, but I'll just hard code them in for now. And then we want to define the render method for this mailbox. So what we could do in the render method is have the mailbox render all the kind of UI for the banner and the headers and the toolbox and all that stuff, and then also all the render logic for each individual message. However, that would make the mailbox component pretty huge. It would make it tough to work with, and also it would be doing way too much. It would be quite tricky to test. Instead, and this is a really common pattern in React applications that you'll come across pretty soon if you start working with them, what we'll do is we'll create a smaller component called message, and that component will be responsible just for rendering an individual message onto a screen. So in the render method for this mailbox component, what I'm going to do first is pull the messages off the state. I'm then going to map over each message, so that messages is an array of message objects. And I'll return a React element, a list item. It has a key so that React can identify it. That's kind of an implementation detail. But more importantly, for every message in my array, we create a new instance of this message component, giving it the message that it needs to work with. We store this back into this array called mails, and then at the bottom, we can just return an unordered list with those list items inside it. So now the mailbox is responsible for rendering the overall UI, but for each individual message, it delegates that to a smaller component called message. And the message component can be whatever you like. I've just got kind of a dumb render in here. If you take a look at this now, and there's an example on JSBin for you to play with, this is much nicer. We've got two small components, and one does one bit of work, so the mailbox does the whole UI, deals with storing the data that makes up the messages, but it hands off each individual message to a different component that knows how to render a message. The moment you work with any form of list data in a React application, you'll use this pattern. It's pretty common. So now I want to look as well about building more reusable components. I've spoken a fair amount about how we can take components, use them in 2 or 3 different places, maybe use them on different projects. But that can be quite tricky if you've not done it well. An alternative title for this section might be How Not to Hate Yourself in 6 months' Time as a React developer. But say we've created this component, like our person component from earlier, and it takes a couple of properties. It expects to be given a name property, and it expects to be given a color property. And I render it with name equals Jack and color equals blue, and I get the exact behavior I'm after. However, say I'm using this component which someone else implemented on another project, and I don't realize that it needs to take two properties. I just give it color equals blue, and then we get broken behavior. Maybe I forget at all that it needs properties, and then I just get even more broken behavior. It's easy to remember the properties on a component when you've just worked with it, but the moment your colleague has implemented it or you've not worked with it in 6 months, it's going to be quite tricky to remember what's going on. And hunting down bugs and issues like this is pretty frustrating. React provides a solution, though, in the form of prop types. This lets you specify on a component what properties you're expecting to get. So first, I just pull that off into a variable called types, because React.proptypes is quite long. Then in the component, I define this prop types. And I give it an object of all the properties it's expecting, and I can tell it what type it should be. So in this case, I'm saying they're both name and color are both strings that are required. You can also do types.array. You can do arrays of objects. You can do all sorts here. It's pretty in-depth. And then when I'm working in this React app, if I fail to pass in the property, I get a really nice console warning from the React tooling. So now, I've not spent hours debugging why my component isn't behaving like I would expect it to, because as a developer, I've documented my component, and I make sure there are errors in the console. So definitely do this. You should absolutely do this by default when you're building React applications. It's worth also noting that prop types are avoided in production. So React has two builds. It has a dev version and a production version. The dev version does a lot of extra checks that the production version doesn't. So you don't have to worry about these checks on prop types slowing down your application in production, because they're only checked in development mode. So I've got 3 minutes, so we might have to do Q&A offline rather than on the stage. But I just want to quickly talk about the lifecycle of React components. So I'm not going to go into this diagram, but I've got this diagram here which goes through the entire lifecycle of a React component. When it's first put into the browser, when data changes in it, when it's then removed from the browser. And I've also put the link here for you to grab as well, because it's really important to get familiar with the lifecycle of a React component, and also all the methods that React lets us define so we can hook into various stages. They're all documented at this URL as well, which is more for when you check out the slides later. The one that's most of interest to us is component will mount. This is a method you can define on a React component that React will call for you just before it's going to put that component into the DOM. The best use case for this is talking to an API. If you've got a component that needs to fetch some data from a URL and render it, you want to kick off that process the moment you know that React is about to render that component. So if I've got a component called GitHub person, this is going to render some data from the GitHub API. I first define the initial state. I'm going to have a key called data, which will be the result back from GitHub. And I initially just set it to an empty object. I then define component will mount. This is a function that React is going to call for us at the right moment in time. I call getData, which is my external function, which goes off to the GitHub API, returns a promise. And then when I have that data, when the promise has given me some data back, I'll call this .setState with that data. Then in my render, I can return this .state.data.name and this .state.data.company. So then the moment React knows that this component is about to be rendered, it will call component will mount. That will kick off the asynchronous process to go and fetch my data. And when it comes back, React will re-render with the data that I've just got from the API. And you just about make out that does indeed say Jack Franklin from Pusher. So there's loads more to cover. There's lots more I could have talked about, but I'm unfortunately mostly out of time. This blog post in the React docs talks about thinking in React. It actually breaks down how to take this idea for an application and build it as a bunch of smaller components. That's a really good recommended read. There's so many more things I haven't covered that I'm happy to talk about offline. I'm around for the next 2 days. Feel free to come and find me. Things like universal React, so running React on the server side as well. React Router for nice URLs, Redux or Flux for dealing with complicated data, how to test React applications, React Native React and CSS modules. There's so much stuff going on in the React ecosystem, and I'd love to talk more if anyone wants to just come and grab me for a chat. I'll be at all the parties as well. And finally, just to leave you with a closing thought, one of the best things about React is how much code you write that's just plain old JavaScript. Unlike an Angular or an Ember and those frameworks, which are great and definitely have their place, React deals with just the view layer. It just provides you with this idea of components. That means anything extra you need, you might have to write yourself or build another library or install another library. But it gives you a lot of control, and it also lets you pull out any code from a React component into just plain old JavaScript. If you've ever found yourself getting frustrated with a bigger framework because you have to hook into its module system or its idea of factories or services or whatever it might be, I'd really encourage you to have a look at React, because I've really enjoyed how React doesn't do that. Yes, it's maybe a bit more work sometimes to hook the different pieces together, but it's really nice as a developer to just be able to write plain old JavaScript functions. So that's all I've got for you. There's the official React docs, just for the slides. I'll tweet them after I get off stage. I don't know if there's any space left, but I'm actually doing a 3-hour React workshop tomorrow on the workshop stage in the afternoon. So if you're interested in that, come and grab me or just turn up. If you're not interested in that and you happen to want to go to London in June, I'm doing a full-day workshop on React in London. There are tickets available. The URL's there. Feel free to come and grab me. But that's all from me. That's my Twitter, that's my email, and that's my website. Enjoy the rest of the conference, and thank you very much for listening.
Thank you, Jack. We have one question from the public.
Cool. Yeah.
How is the client state stored on the server side?
So React doesn't deal with any form of syncing data from the client to the server or vice versa. You have to write that all yourself. I've tried to avoid syncing the two up. What I'd instead do is just have the client make HTTP requests from the server to fetch the data, and then any new data changes are posted back via HTTP.
We're down?
We've been kicked off. Oh, there we go. So yeah, you can. There are libraries that will try and attempt to sync the two up. I found that to be quite brittle and easily breaks. So I'd rather just have the client make requests to the server and post data back up to it as well. But if that's not enough, please come and grab me, whoever asks a question.
Thank you very much, Jack.
Thank you.